The session has been started, recording.
Okay, all of you can see the session also?
Yeah, we can see your screen.
Yes.
Okay. So today we'll discuss about functor. So before I'll start the functor, so we all already have knowledge in the Haskell, all these things. Okay. So one of the part of the function is that it's a functor. Functor is actually a type class that provides actually two types of methods. One basically called as a FMap and another thing is called as a function. So mainly the functors is specially used for maybe in the use for the join concept or maybe in the maybe type. So here it is only used in case of IO function. Okay. So first important part is that we have to discuss here is that we are implementing the FMap in case of functor. So map also is there, we have already discussed, and this is also FMap where we are using in the functor. Functor is already using the FMap concept. So functor is actually it is a data type that is mainly using or implementing the functor type class. And here in case of this, I'll just giving one of the example here. Just wait 1 minute. Actually, my screen has been squeezed.
Sir, if you're having issue, I can share my screen.
Yes.
Yeah.
One second.
Actually, my screen has been squeezed. Just a second. It's not enlarging. Okay.
Is this fine, or I need to share my screen?
Actually, my screen has been squeezed.
Okay. Okay, sir.
That's the only reason. Actually, I'm just enlarging it. It's not enlarging.
So then do one thing. Stop sharing. I will reshare my screen.
Okay, you share it. Okay. Thank you.
Yeah. So
Yeah.
you can start explaining.
Okay. Now you can see that here we are mainly using here the map concept. So in the functor, the map function can be applied to nothing more than the list of the value, where the value are any type. The question is that what is the any type? The list of value means any type means we can use integer, we can use float, you can use any string, whatever thing we can provide the values. Whereas the FMap function can be applied only on more than data types, such as we can use maybe, you can use tuples, we can use list. Mainly you can see that list and tuples. List means the similar type of values in an array, where tuple means dissimilar type of value in an array. In a list, we can have integer type of value 10, 20, 15. But in a tuple, we can have a string type, a integer type, a double type. This type of value is also available. And in this FMap, but we can see that when you define the list of values, the data type is also called as a functor because it produces an implementation of this. Then the FMap is mainly used to give the result same as map. So map we have already addressed that. What is a map? Map means a key with a value. A key with a value. So FMap is also concept same as, but FMap is mainly used in case of functor. That's why we are providing always giving the concept of FMap. So in case of functor, we are basically, it's a kind of functional representation of different types which can be mapped over. Mainly it is called as a functional representation of different types. Just previously we have discussed list, tuple, maybe, or different types, whatever we are using it here. So this is called the different types. Here you can use list, here you can use map, where you can use trees, where you can use set command. So everything, this is called different types where we can use in the functors. And one of the biggest advantages of functor is that it is the concept of polymorphism. And we all know what is a polymorphism because if you have knowledge about the OOPS concept, in object-oriented programming language, polymorphism means that is a many form, many activities. Means we have a constructor which can have a default constructor, a parameterized constructor, a object-oriented constructor. That means the class name is having the same as the function name. So same way, though it is a pure functional based language, so the OOPS concept is not there, only purely functional programming language. But it is also using the concept of polymorphism. Here the polymorphism means using the FMap, how we are passing the different type of values to the functor. So now we have to discuss about how to use this one. Now you can see that here I'm using one basic example. Now class functor f. Now you can see that FMap, that scope relation. Here is the function we are using. A is pointing to B, where the functor A is pointing to the functor B. That means the FMap using the value here is that A is pointing to B. So in this above definition, what we can see that functor is just a function because you can see the top one where I've defined that FMap and within the bracket less than dollar symbol bracket means functor is using a function definition. So now here in this here we can see that FMap with A pointing to B within the parenthesis bracket. This is a function. So you are using a function. So the functor is a function which takes a function and the function name itself is called a FMap. FMap itself is a function and it returns another function also. So when we define a function and it returns another function, then this is the using of a functor. So FMap is a generalized representation of a function, map function. So FMap is actually we are representing it from the map function. Now we have used both the map and FMap function in the programming, but here you can define it. I'm giving you one of the list command here. So you can see that we can observe that both the statement will yield the same result of a list containing the elements 1, 3, 7, and 15. So now you can see that whatever the given is there, so we have to specify it, we have to subtract the value. But before going to the program, Just I'm giving you one of the example here. Both the FMap and the map function, just I'm using as a subtract. So go to the program side. So here what you are defining here, the main programming is there. So in the main program, what you can see that we know that main is a, here it's a IO function equal to do. We already know that do is a block. Just like in C, C++, if you have knowledge in Java, so you are writing any main function, then you are writing the curly braces, open and closing. Inside the opening closing curly braces, you can write some statements also. In the C also, C is a functional programming. In the OOPS concept or in the class concept, we are writing here. But in case of Haskell, we do not have any curly braces or opening. To open any block, we have to use like a do command. You can write a do command, or you can write a single statement main is equal to printf. If you write multiple statement, then you have to write main is equal to do. Okay. Anybody is out? Devasis?
No. Okay.
Okay, you are getting me. Okay, Arata, you are getting me.
Yes, sir. Getting.
So Arun sir, you are getting me.
Yes, sir.
Okay, thank you. So do is a block. So even that block, we can write multiple statement below. So you have written two print statement. Now I'm giving one example of Functor because I am asking you the Functor. Functor means it is giving a function and the returning value is also a function. But now here you can see that print map. Also I'm written print FMap. Both the results are same. Here you using also map, you can get the same output. Using the F also, you are getting the same output. So in the map, what you are writing, a function we are defining, map is a function, and inside that we are also using a subtract, and that is also one is also another function. Okay. So inside here, because whenever you are using a function inside a function, in case of C, C++, we are writing a function within bracket, then we are writing a function within bracket, we are passing the argument. But in case of Haskell, you can write it if function within bracket, then you can write a function, you may write bracket or you may not write bracket, it will be accepted. Now though it is a pure functional programming, so we are using that fmap within the bracket, we are passing another function that is called subtract 1, and that function value is taking the value into the list, because you can see that the map itself is a function and it is taking the value to the list. You can see the array list, that's the list 2, 4, 8, 16 other two different lists. So whenever, and same thing also we are using for the FMap. Okay, so output of the both, whenever you are going to get the output of the both, now you can see that what actually we are doing it, we are doing it subtract. Now my question is that what actually the value we are getting from this, because I told you in case of Haskell we always prefer to do all functional programming, and all the functional programming means we have to pass the argument from a function to a list to do a operation. We cannot directly do any operation in the list to a function, but we have to pass argument from a function to a list. Now my question is that whenever I'm using the f map subtract 1 2 4 8 16 and again f map subtract 1 2 4 8 16, so my question is what will be the output, whether it will show an error or whether it will give you a result? Anybody? Devasis?
I think the subtract function one will 3 sorry 1 3 7 15 output will be.
Okay. Artha?
Yeah, maybe same one. I think that will be minus subtracting 1, 3, 7, 15.
Arun sir? Okay. So now question again arises. So what may be the output? Let me, before I'm just going for compilation. Okay. So now you can see that output here 1, 3, 5, 7, and 15. Now question arises that map is a function. Okay. So what is a subtract? There is
That is
a
also a function.
function. And what is argument is passing?
1.
1. So subtract, whenever you're passing the subtract to 1, to whom we are passing? To the
The map function.
map is a
That
function, subtract is a function which is passing
function,
1.
one
Okay.
argument, and to the
To
argument
the
of the map function.
map function to whom? To the map list. Okay.
Map
So
list,
when you're
yes.
passing the list, so automatically it will be deducted 1 from the list. Each element of the map, that a list will be deducted to 1. Clear? Any doubt is there?
Yeah, clear.
Okay. Now again, this is the both
Sir,
FMap also.
Prasanna,
Okay.
sir, I have one doubt. These two function, the map and FMap is okay, and you have said that the working criteria is different for FMap. I just
No, both the maps are same, not the working capital is not. I told that FMap is actually extending from the map in case of functor. Okay, but one of the important part is that till now we have not gone the entire part of the functor. Whenever
okay.
you are using for the different type, just like maybe you are using, just like we are using the just data type we are using, or nothing we
Okay.
are using. In that case, we can use the FMap, not the map.
Okay, got
That's
it.
why I'm just giving the example. Again, we have to go to the top side. So we have stopped where both the function called another function. Got my point?
Yes,
So
yes.
this is that. Just take it off. Okay. Thank you. So here you can see that both the both the functions call another function called subtract. Now we can get it that whenever you are defining any FMap here, you are using the function. Clear? But now we can see that I am writing a map plus 3, then a list of 1.5. So here also FMap plus 3, just 15. Now you can see whenever I'm trying to compile the FMap, so below you can see that I'm writing the FMap plus 3.
Just 15.
Just 2.
Just 2.
Just I'm writing GSI compiling FMap within the bracket plus 3, then just 2. Then question is arises, what is just? Just is also a type class. Okay, it is defined from the data type. That's a type class you are using here. But here, what you are defining here, the plus 3, just 2. Then what will the output here? See there, what is the output here?
5.
Okay, that means 2 we have taken and we have added plus 3. See here, now here is that, sorry. So in case of here, we are using the different data types that is called just. So just and nothing other 2 data type here using that. But here we define that plus 3 just 2 means we are adding plus 3, that is the function argument as a plus 3. Plus 3 means this is here we are using as a operator, as a argument type using the function where we are passing the 3 to the just 2 and making add as a 5. So now the output will be the 5. Okay. So you can see that whatever the business has written here, so it is giving the just 5 is a output as a 5. Clear? Hello.
Yeah,
Prasanna sir, clear.
Can you increase the screen size a little bit? Because it will be very less. Yeah, it's
sure.
clear. It's clear.
Okay, okay.
Can you speak louder? I think. Sorry, increase the size, zoom size. Top of that 74, no? You can little bit plus. It will be increased.
Okay, okay. Okay.
I think. Yeah. I think. And
Is this fine?
Okay,
I
is this fine?
Uh,
Yeah.
Actually, I have opened this one. I mean, I'm inside VS Code, so yeah, I'm just.
Yeah, yeah.
Okay,
That's
no
the-
issue.
This is open in the VS Code, so it cannot be enlarged. Okay. That's
Okay,
the
okay,
size.
no issue. Okay,
Okay,
fine.
okay. Okay, thank you. So now again, the second part, you can see that the code. Here in the second code, you can see that what I have did in the second part. Before the map, FMap is there, below the another part is there. What you can see that +3 within the bracket. What I have written there? Which symbol?
Dollar.
Now question is that, then what is the dollar here? In the first line, I have already given you the syntax. In the first line, I've given you the syntax is that FMap and another part is what? You can see that. FMap and which symbol is mentioned?
Yeah, it's dollar for structure preserving transformation.
Okay. So it is defined that less than symbol with dollar symbol. Okay. So
Yeah.
whenever also I'm writing the same code without using the FMap, I'm writing the +3 then dollar symbol just 2. Okay. The output will be same. There's no difference. Same thing, it will be added to the just there. So here using as a FMap. See, in the place of FMap, I can also use a dollar symbol. Got my point?
Yes.
So you can use both the concept. Either you can use the FMap or you can use this symbol as a function. Okay. So this is mainly used for the Haskell. Okay. That is also another concept is not using concept as a nothing. When we are using this example, just Bisu sir, click the nothing, just nothing function program. Okay.
Yep.
Now you all of you see that the same programming also written here. Now my question is arising here. Whenever you are going to compile the program, first one is same FMap, then the +7, just 10, FMap +7, then nothing. In the first statement, what will the output? Rajiv sir.
Yes, sir.
So can you tell me just any doubt, anything is that regarding till now?
Just checking it.
Devasi sir, any doubt till now?
No doubt.
Okay, can you say what is the output here? I have not told you about nothing. Nothing means nothing. Just means just hold a value, then you pass a parameter, either adding or anything, then it will add it. Then question is that nothing. What is that nothing? Can you tell me the output?
Nothing might be 0, and that 2 add 7, that becomes again 7.
Or
Maybe not
maybe
clear.
first one is 17
Okay.
and second one is I think 7.
Okay. Anyone? Arthur sir.
Yeah, last one is 17. Second one is, I think, 0. 7 doubt.
Okay, fine. It's no problem.
It's
And
already
Raju sir?
run.
No, wait.
You have run it already. Just 17 and nothing.
Okay. So thank you, Vishwaji sir. So after running, you can see that all of you have accurate answer. The first thing that just 17 means I told you actual thing that you have a block. Okay. So you have a node. Inside a node, the value is 17. Just contain a node value that contains 17. So we have already learned some data structure or whatever thing. So till now we know that just here is a one value which contains the 17. So whenever you add it, then it will value is present inside the just, so it will add it. Then that will give the output as a 17. But in case of nothing, the node contains no value, not even a 0, not even anything. This is simply empty. So that's why it is returning nothing. It is not a 0, not this. Hello.
Yes,
Okay,
it's
got
clear.
it.
Clear.
Hello.
Okay.
Hello, Prasanna sir, got it.
Okay, got it. Now,
Yeah.
so we know that this means what? Just means that contains that value which is nothing. So until and unless we get the value, so we are not going to this. Just 1 minute. All of you hold it. So I just have a drink of water. Just 2 minutes.
Sure, sir.
Okay, sorry. So let's start it.
Yep.
Oh, till now, any doubt? You have anything?
Prasanna sir, I have one doubt.
Okay, gracias.
If we are not doing anything
Okay.
for the nothing statement, then why we need this actually?
Which one? The nothing function.
The nothing
Nothing type class.
yeah, nothing, in nothing there is no value, and
Okay.
nothing is there basically. So then why this statement is required?
See that I told you just now that we are using the different type classes that is been predefined by the Haskell. Okay. So whenever you are defining nothing, in some cases, in some programming concept, or whenever you are doing some programs, we have to define that it is nothing. We have to store the value that it is nothing. We should not implement it. But in the FMap also, when you define as a nothing, the value always store a nothing value. So for example, take an example that so when you are applying a function with a 2 with a nothing, okay, then we can context it to another value, define that it is a 5, then it will add that 3 plus 2 is equal to 5. But nothing, always define a nothing. That will be, we'll discuss more when you will go for the functor in applicative or any other part. Okay.
Okay.
Because that is the main, means simply another one of the point I'll tell you, basic example. Let's forget about it. We have a knowledge in C, C++ data structure concept. So in case of data structure concept, you can see that we have a number of lists are there. We have number of nodes are there. So when each node contain a value, at the end, the last node contain what? Nothing. That means the entire node will be completed at the end of the nothing. Means you will go for the first node, will get the node of another by the address location. Then it will go to the another location node. Then it will go for the another node location with the having maybe the through the addresses with getting to the value. But at the end, the last node does not contain any address value or any value that will be stopped. That is called nothing. Okay.
So there is some condition where we need to means define that
to end up any things, we have to go for nothing.
nothing. Okay.
Because if will not end up, how to end up? Because if will have a value, then we can say that it's not end up. So if we'll go for the advanced Haskell programming, just like we'll go for the smart contract or any Plutus programming, there we are mostly use this concept. Because whenever you are defining anything else, at the end we have to define that this is a nothing. The thing nothing means it will stop there, it will not proceed. Okay.
Okay.
Thank you. Or anyone, any have any doubts?
Prasanna sir, can you just explain what is just again? Why that just is used?
Just is a type class. Simple thing, just is a type class. Okay. Because we are using functors and having the FMap is a predefined function. Same thing that just and nothing also defined as a predefined. But if you want to also define it, that make it as a you defined. Okay. So you can use the keyword called data with just, you can define it, or just, maybe, and nothing are the three defined type classes which has been used in case of functor. Another keyword we have not till now discussed about the maybe, M-A-Y-B. So we'll discuss in next class. Okay. So these are the basically type classes we are using here. But if you want to define your own type class, you can use the keyword called data, D-A-T-A, data, small letter. Then you can define that Rajiv. So Rajiv can be defined as yourself. Then you can define with any types, int, float, structure, any string, any type you can define. Okay.
Okay. Now suppose I will write 10. Writing 10 and just 10 are same thing.
Yeah. It's not clear, audible. Okay.
If I will write 10 instead of writing just 10, both are same. The result will be same, I think. If I write the first statement, print f
I believe
plus 7.
just 10 will return a number before just. I mean, here you can see we are adding 10 with the number, but it is returning just 17, not only the 17. So if you write the numeric number, it will only return the numeric value.
Okay.
It means it will give 10. 10 will be returned with 7.
No. Yes. Whatever Vishesha told you, that it's the same concept. But whenever you are using a function is here, okay. So same thing that if you are not writing just with the help of 10, so automatically it will show an error, because FMap, whenever we are using a function FMap and we are adding +7, the FMap, the function specially used for in case of just, nothing, and maybe. So if we try to add +7 with a 10, then it automatically 10 within the bracket will be a function. Got my point or not? Hello.
Yes.
So if we try it, it will immediately show any type of compiling error. Maybe define that it is a we are not defining any arguments here. Okay, the FMap is a function. It defined with a value which has a +7, and you are trying to write on the side a 10. It can identify what is 10. That's why it will show an error. That's why we are using the predefined function just, or maybe, or nothing, that we have to use it. So maybe I have not told you what is the maybe, but regarding nothing and just, I have already told you. Just means you define the value that this is the value you have to add 7. That's why you are writing just. That is basically a type class we are using here. All are predefined. And this is what actually till now we have already discussed, that whenever you are reading a Haskell, everything is a functional programming and it has been predefined. And we have to maintain the rules and regulations of all the predefined functions. Okay? Any doubt? Anything? Within the do block, whenever you compile it, in the do block, it will show an error. So if you will not write just, if you will not write nothing, it will also show an compiling error. Got my point? Hello?
Yes, sir.
Okay. So anybody any doubt? Again, my question is arising here, all of you. Suppose I'm writing the FMap function, okay? We are writing. So here we have also keep the within bracket +7 and within the bracket just 10. Question again arises, if will not define the bracket in the just concept, what will the problem will arise? Whether it will compile successfully or it will show an error.
Yes, you are saying FMap bracket +7 bracket, then just 10 only.
Just 10 will not be in the bracket.
Definitely it will be error.
It will not show any error.
It will not show any error. Anybody?
No, it will show error. Okay. Because
What
we
type
are
of
not,
error it will show?
because we are not defining any, so
We are defining just 10 because FMap is there, bracket with the bracket is there. But I told that in case of just, we are simply removing it. Rajiv sir, any error or any output?
Error.
Why error? Because till now we have already covered is a functional programming language. Everything should be defined inside the function. So you are writing the within the bracket, define that just is you are using a FMap. Within the FMap, I told you that whenever defining a two types of function within a function, you are writing that f is a function within the bracket, then g within the bracket, then x, then bracket close. But inside the function,
Just is a
we are
function.
not defining.
Just is a function. No?
Yeah, just is a type class which is act like a function. Okay, so you have to define inside the bracket.
If it is a function, then we have to write it in a bracket.
Okay, clear. So it is a type class. Okay, defining as a working as a function. Everything is working as a function. We know it that everything is working as a function. But in case of nothing, we are not writing here because we are not passing any argument. Simply we are writing nothing. So we are not defining within the bracket. Okay. Clear? Devasis, clear?
Clear. So whenever we are passing the argument, we have to put the bracket.
Okay, sure. That's because it is a pure functional programming language.